So this is going to be objective 39. We are going to graph linear inequalities, and we're also going to tie in systems of linear inequalities. So the first thing is you need to know how to graph just a regular linear inequality, and then after we get good with just graphing one, then I'm going to go back and add in what do you do when you have two of them, because that's a system, right? When you have a system, you have at least two or more. So what do you notice about these graphs? Because I got some examples up here. They're shaded. So let me get my fancy dancy ruler. You go ahead. Okay, so I want you to pretend this is the line. Tell me. Everybody agree there's an x and y on this point?
Yeah.
Everybody agree there's an x and y on that point?
Yeah.
Everybody agree there's an x and y on that point? So tell me about the line. You should know about the line. What if it's straight? It is straight because it's linear. Okay? It's not quadratic, right? So, but tell me about these points. What if I take a point that's on the line? What if I take the x and plug it in, and what if I take the y and plug it in? What happens to the equation for that line? It becomes balanced. Be a little more specific. Balanced, it means it becomes equal. So the line, I need you to understand that. These points that are on the line, those are the points that I can plug in. I can plug in the x, plug in the y, work the two sides out. It makes it equal. Okay? Well, if it's an inequality, if it's not equal, it's either greater than or it's less than. So what would these points up here make it? If the line makes it equal, the points above it make it greater. Above, greater, should make sense. The points below make it, say, less than. If your line is like this. On the line makes it equal. Above it makes it, again, everybody agree there's points all up here if this was a coordinate grid. If I took that point, everybody agree that has an x and a y right there. If I took the x, plugged it in, if I took the y, plugged it in, it would make, from left to right, it would say this is greater than that. It would make it be greater, okay? And the points below would make it less. So you tell me. Equal, greater, less.
Equal, less, greater.
Mm-hmm.
Equal, less, greater. No, less.
Why less? Left side to the left is negative. These are your negatives over here. To the right is positives is greater. Okay? And equal. Here we go. A couple more.
Equal, greater than, greater than, less than.
Is it on top of the line or is it underneath the line?
Greater.
It's greater. Okay? Equal.
Less than.
That works. Okay, so do you understand the concept? On top of the line is, we'll make it greater than. I'll show you in a minute how it makes it greater than. Below the line, so tell me, what is this shaded? This obviously is an inequality that says that we want the points that are less than. We also want the points that are equal. So it would be whatever is less than or equal to. Okay? What about this one? That one's less than or equal to. This one is, it's less than, okay, or equal to as well. All those are less than, okay? And we'll show you what to do when it's not equal to. So, all right, here we go. First things first, do you recognize this form? Yes, what is it? y equals mx plus b, even though it says y is greater than or equal to 2x plus b. So tell me really quickly, because it says y is greater than, because we read from left to right in America, right? Y is greater than, where do you think we're going to be shading? We're going to, whenever we plot the line, we're going to shade at the top, okay? So, first things first, where's our starting point? Up 3. So we're going to start at the origin, we're going to go up 3. Again, this is your y-intercept. This is slope-intercept form. That's what it's called, slope and your y-intercept. From there, where do I go? Up 2 over 1, up 2 over 1. This is a good review of slope. Down 2, left 1, down 2, left 1, down 2, left 1. I would encourage you to put lots of points so that you make your line nice and straight. Okay? Does it make sense that my line is rising? Yes. Okay. So, from here, we need to, right now, all I have said is the line. And so right now, this says that y is equal. These are the points that are equal. That's all I have said on the graph. Does that make sense? And again, if you pick one of those points, and I'll show you that it's equal if you don't believe me. Pick a point that's on the line. 0, 3. 0, 3. Everybody agree? 0, 3. Which one's x? Which one's y? Okay, so let's put a 0 for x. So here you go, and a 3 for y. 2 times 0 is 0, and 0 plus 3 is? 3. Aha! Doesn't it make it equal? Yeah. It makes that side equal to that side. The points on the line, any of those points will make it equal. I better put this down or I'm going to get in trouble with this thing. I'm having fun with it. Okay. So we also, not just equal, we also need to make it, we need the points that would make it greater than. Does everybody understand that it's greater than? So would I shade A or would I shade B? A. You would want all of these points as well. These points, yep, she is going to have a good time coloring today. Lots of coloring today. Okay, so tell me, pick me a point that's in the shade. You can check a point. Pick me, and if I were you, when I pick points to check, I pick easy points. Don't pick something that's all confusing. Pick me an easy point. What did you say, Dylan? -3, up 1. Okay, so that works. Great minds think alike. -3, 1. Which one is x and which one is y? So let's put the 1 for the y, and let's put the -3, and let's see if it makes it truly greater than. What is -2, or 2 times -3? +3 is -3. Is 1 greater than -3? Does it make this side greater than that side? It makes it work. Does that make sense? Any of these points would work. Okay? You know what they're going to do on the SOL for you? They might say which picture matches. So you would look for a picture that looks like this with all the shade over there. Okay? But they might say, they might give you a blank graph. So I'm going to go back. They will give you a blank graph. Now you have your graph. And they will say, plot 3 points that would satisfy this inequality. So again, what would 3 points that make it greater than or equal to? What can someone give me a point that would work? -4 up 1. Could I plot that point? Yeah. Why? How do I know that that works? Because it's in the shade. Does it make it equal? Does it make it greater than? It makes it greater than because it was in the shade, right? Give me another point that works. -5, 1. Does that point work? Yep. Give me one more. Oh, y'all are getting good with those. Okay. What if I said, give me 2 points that would make it equal? You give me one on the line. So give me one on the line. -3, -1. -2, -1 was on the line, and 0, 3 was on the line. If I said, give me 2 points that make it equal, those points in the shade make it, did I not do it right? Maybe it was this one. Is it that one? -2, -1. So how about that? Does -1, 1 work? Yeah, that works. Okay, so that would make it equal. Sorry about that. Okay, but then again, sometimes they might want the whole picture, and sometimes they might just want points. And here's the thing. How are you going to get points without you drawing the picture on your paper? You're not. So what would I say to you? Graph it out. That's our motto. Graph it out. Draw the picture. Graph it out. I can't make you, but I best see on your scrap work lots of little graphs. Okay? All right. Here we go. You take a minute. Is that in mx plus v?
Yeah.
You take a minute and graph that. Okay? You take a minute. You should have a line down 1. And we should go 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Or negative left 1. Negative left 1. Negative left 1. Again, wait before we shade because I got to do something here. Okay? How many did not graph it correctly? Did I mess up? Like you maybe run then rise instead of rise over run? Don't forget, we get in an elevator. But if you don't remember, you can go to y equals and put it in. And then you can go second graph. It gives you a table. And on that table, you'll see 1, 2. Can you plot over 1 and up 2? And then you'll see 2, 5. Can you go over 2 and up 5? Then you'll see 3, 8. Can you go over 3 and up 8? Does that make sense? It gives you the points to plot for that line. Okay? Now here's the thing. This says that y is less than. Well, what do I have right now? The line tells me that I'm also including equal. It's not equal. I don't want the line. So you can't just erase the line because it's like you got to have a boundary. Have you ever in your room, like with your brother or your sister, had an imaginary line or, you know, this is my space, this is your space? Does that make sense? But the line's not really there. You still got to have a boundary to separate the less than and the greater than. So what you do to say that these points don't work is you make your line, and I'm not going to be able to do it. Well, I can now. You make your line dashed. So you use the line for the boundary, but this says that these answers don't work. Yeah, they don't work. Because if I took these points and plugged them in, it would make it equal, and it doesn't want to be equal. Does that make sense? I only want the points that are less than. So, do I shade A? Do I shade B? B. So you want all of these points. Okay? And I'm going to prove to you that this works. Somebody different, besides Dylan or Taylor, because they've given me answers today, somebody give me an answer that works for that. Give me a point that would satisfy that. I hear 2, 1. Over 2 and up 1. Do we agree that that point should work?
Yeah.
It's in the shade. If it's 2, 1, which one's X, which one's Y? X is 2, so let's put a 2 here. And let's, a 1 there, and let's check it out. 3 times 2 is 6, and 6 minus 1 is 5. Does it work? Is 1 less than 5? Does it make it less than? You follow? Okay. Could I pick this point?
No.
Why not? Because it would make it equal. And it won't say, it'll say something, if I plugged it in, this is over 1 and up 2. So if I did this, check this out, 3 times 1 minus 1. 3 times 1 is 3, and 3 minus 1 is 2. Is 2 less than 2? No, it's not less than, it's equal. So you would not want one of those points. Okay, give me one more point that would work. Over 3 and up 3. Does that work? Okay, so any point that's in the shade will make this less than that. Okay? What's different about this one? What is it in? It's in standard. AX plus BY equals C. And don't forget about your two no-nos. No fractions and no negative A's. Do y'all remember that? Okay, but what would we do probably to graph this? So why don't you take a minute, this is good practice, good review for us, rearrange that, solve that to y equals mx plus b for me. Before you graph it, we'll check. Tell me the first thing to do. Okay, move this over. I'm left with negative 5y is greater than or equal to negative 3x plus 10. Now what? Now what? Hang on. Divide by negative 5. So, it does say greater than, but why switch it? The rule says when we multiply or divide, see, this is a good review for us. When we multiply or divide by a negative, you must switch your greater than or less than sign. Do y'all remember that? So when you multiply, and everybody agree we're dividing by negative 5 here, here, and here? So this becomes less than, keep going, Wes, positive 3 over 5x minus 2. Very good. Okay, then you're going to plot this line. So we will go down negative 2. From here we will go up 3 and over 5. Everybody agree? Up 3 and over 5. Or you can go down 3 and left 5, down 3 and left 5. Do I want a solid line or a dotted line? Why solid? Because it's equal. See, we want it to be equal, so we want a solid line. These points, do we want those points?
Yeah.
Yes. And we also want the points in shade A or shade B. B. Why B? Because it's less than, underneath. Okay? So we also want these points. Any questions on that? If it's not in mx plus b, you got to rearrange it to mx plus b. Okay? What would happen if I picked one of those points and plugged it in? It would be less than or it would be equal to. It would work. Okay? Would you plug it into this or would you plug it into that? Does it matter? It'll work for both. But again, when you decide, everybody says, but Ms. Gorns, I thought that said greater than. And so we would shade above. When you're deciding whether to shade less than or greater than, you got to do it based on the one you're graphing from. We're graphing from mx plus b. So you got to shade below it, less than. Okay? Can I skip that? Yep, okay. Let's go to this one. We'll make this 4. Whoa. Why don't you take a minute and graph this, and I'll offer candy
I got you.
for who gets it right. First of all, most of you remembered that, first of all, some of you gave me an angled line. Is this an mx plus b?
No.
No, this is one of them, shh, hush. This is one of them weird ones. You with me? Why is it weird? Because it doesn't even have an x. So it's either this kind of line, which has what kind of slope? Undefined. Vertical lines are undefined. Or it's this kind of line. Okay? So if it says y, what direction do we think? We think this way, but what is it really? This way. Okay, so most of you got that. Okay, how many got that it was a horizontal line? Okay, So most of you got that. You know, you could put this in your calculator, by the way. Okay? Y equals 1 and put it in, see what it looks like. But, so, where horizontally? I have to go to where y is 1. Where's y 1? Up 1. And here's the thing. Do I want a solid line across?
No.
I want a dotted. Some of you gave me a solid, so again, I was being picky. Sorry. Okay? So first of all, I don't want any of these because I don't want it to be equal to 1. I want it to be greater. So would I shade A or would I shade B? A is greater. So a lot of you had this, but you shaded below. A lot of you had that you had the line and you had it shading above, but you did not have a dotted line. Okay, and some of you didn't shade at all, one way or the other. Okay, but it should look something like that. How many of you were like so daggone close? And Miss Corns is just mean because she was being nitpicky, right? Okay, a dotted line and a solid. Dotted line means that it's not equal to. That means that these points right here, if I plugged any point that's on the line in, it would make this equal to that, and that's not what that says. Okay, now, if I throw a little equal to underneath, then you'd be a solid line. Okay, all right, so we'll make this 5. Nope, nope, because I'll give you one in a minute for candy. I'll give you some more. Give you more chances. Can you put this one in your calculator? No, you can't put this one in your calculator. Because it's x equals instead of y equals. So first of all, where do you go if x is 3? For x to be 3, you go to the right 3. And here's the thing. If it says x, what kind of line do we think? We think x-axis, but remember it is the opposite. Do I want a dotted line or a solid? Dotted. So we want a vertical line. Don't forget, this vertical line has a slope of 0. Oh, no, excuse me. I'm sorry. You're right. Undefined. I don't know. I heard somebody say 0, and I said 0. Undefined. Vertical lines are undefined. Okay. And if x is less, we shade to the left. Less is left. Okay. So there is your points, and you could still pick points. Pick me a point. Pick me the easiest point up there to plug in. 0, 0, right? I could plug in 0, 0. Now here's the thing. I have a 0 for x and a 0 for y, but I don't see a y. So guess what? You just don't use it. You just use the x. Is 0 less than 3?
Yeah.
It works. Does that make sense? What if you plugged it in and whatever on this side, it didn't, like, it was not a true statement? What if that was not less? What if it was greater? Then you shaded the wrong side. You need to shade the other side. So it's good to pick points in your shade to check it out. Okay? If I asked you to plot points that would work, could I plot this point?
No.
Why not? Because it would be equal. The line makes it equal, and we don't want it to be equal. Okay? You want anything in the shade. Okay? All right. Here is a practice SOL question. Comes straight from one of your practice SOL tests. You don't necessarily need to write this down. I just wanted to show you. Okay? Can I show you how to put this in your calculator? Okay? Now, first of all, let's think through this. Okay? Hang on before you put it in your calculator. Wait. Calculator's down. I'll show you in a minute. Tell me a couple things, like, how many of us always go through and we use those big red X's and, like, eliminate choices? So, can I have 2 choices to eliminate?
Yeah.
Which ones? Y, B, and C. Go ahead. Y, B, and C. Why'd you say that?
Wait, no. Keep reading. Hey. Wait, no.
I need reasoning. Just give me one to eliminate.
Because C is positive.
Okay. Okay. A number 1. What kind of slope does this have and this have?
Positive.
These have. Can I finish? Nice words. Nice words. Okay. These have what kind of slopes? Positive. What kind of slope does your equation have? So we can X these two out to start with. All right. Now look at it. These are the same line. Agreed? Do they have negative slopes? Yeah. With this says Y is less than by B, because B is shading greater than. So you were right on B. I was just waiting for you to tell me why that it was greater than. Okay, so by process of elimination, we already know this is the only one that has a negative slope, and this is the only one that is shading less than as well. Okay, and if you check it, plus 2, and then your slope is down 1 over 3, down 1 over 3, you can check it. But let me show you. Yes, Bennett? Because it's equal to. See the equal to underneath it? Do we want these points? These points, if you plugged it in, it would make it equal, and so it's okay to do that. So that's a great question, okay? All right, let's go to our calculators. Just hang on a second. Here we go. When we divide by -2, here, here, and here, y is less than or equal to 1/2 x. Everybody understand? Not 2x. 1/2 x minus 2. So when we graph that, we're going to go down 2, and we go up 1 and over 2, up 1 and over 2, up 1 and over 2, up 1 over 2, up 1 over 2, down 1, left 2, down 1, left 2. I would check, make sure that you're graphing it correctly. Now, do I want a solid line, Wesley, or do I want a dotted line? Why solid? Because we want the line. We want it to be equal to. Okay? Now, tell me in a minute, would I shade, I'm not going to shade yet, because I'm going to do 2 at one time, but would I shade A or would I shade B? B. Okay? So in a minute, I know it needs to be somewhere down here. Okay? Now, how do I graph the second line? Where am I going to head? Left 2. What kind of line? A vertical line. So solid or dotted? Solid. Why solid? Because it's equal to. Now, if you notice, generally when you plot these systems, it splits your graph into 4 sections. Everybody see section 1? That section. Section 2. Section 3. And section 4. Now, a minute ago, you told me that I needed to go underneath. I needed to go underneath for this line. Everybody agree? 1 and 2 is off. Okay, this says, the second one says that x is, yes, this says that x is greater. So tell me, where's greater? 3. So how can I be underneath this line and greater than that line? Where would I shade? You would shade section 3. Okay, you would shade section 3. Okay, huh? I can't do this one in the calculator. Why not? I can't graph the second one, but I'll show you on the next one how you can graph it. Okay, does that make sense? You have to pick the points that satisfy both at the same time. Like this point over here in section 4, it satisfies what? One of them, it satisfies the first one, but it doesn't satisfy the second one. When you're looking for a system, you're looking for the points that work for both. Okay? You're looking for the points that work for both. So let's look at another one. We're almost finished. There's 10 examples total, actually 9, because this will be 7. Need to renumber them. We're almost finished. Take a minute, rearrange these, graph them, and then see if you can figure out where to shade, and then we'll go from there. Go ahead and take a look up here. I have graphed. Everybody agree? I arranged the first one. You should have y is greater than or equal to 4x plus 1. Everybody okay with that? Did everybody get that? Yes. I rearranged the second one, and I ended up with y is greater than x minus 2. Everybody okay with that? All right, so I have already graphed the first one, up 1, and then I rise up 4 over 1, up 4 over 1, because that's your slope. Down 4, left 1, down 4, left 1. It's a positive slope. It should make sense. Now, if this says y is greater, just tell me, again, in my head, before I draw the other line, I get an idea of where I'm going to shade. Would I shade A or would I shade B? A. So I know it's going to be up top somewhere, okay? Now let's plot the second line. The second line is down 2, and then I'm going to rise where? Up 1 over 1, 1 over 1, 1 over 1, up 1 over 1. Is this a dotted line or a solid line? Dotted, because it's not equal to. Okay, so we have this like so. Okay, now, this says that y is greater, so where would I shade from this? Greater. So you have section 1, that little bitty section in there, section 2, section 3, this little tail down here, and this big old section 4. Everybody see? So what do you think we should shade? How can I be above the solid line and above the dotted line at the same time? 4. No, the only reason I number them, and you'll see this on IE test, you'll even see it on the SOL test, they may label them A, B, C, D. Does that make sense? I'm labeling them 1, 2, 3, and 4 for you so that y'all can clearly, instead of y'all saying that one over there and me not knowing which one you're talking about. So I just label them whatever numbers. All right, let's put this one in our calculator just to check it out, okay? Did anybody figure out that you could get it to go? All right, so I'm going to put the first one in, 4x plus 1. Where do I want it to shade? I want to make it shade up. So I'm going to got it in the corner, okay? Then I'm going to go to the second one, and I'm going to put in x minus 2, and I'm going to make it shade which way? Up. Okay, so they're both greater than, so I'm going to make them both. If you hit graph, there's the first one. There's the second one. Now you see all this extra shade in there. That's because this part and this part satisfies what? One of them but not the other. You want where they are overlapping, where it works for both. The darker part's where it's shaded on both. Does that make sense? It's overlapped. Okay? This works for one of them, but not for the other. Same thing with this. That works for one of them, but not for the other. But this huge section, that's where they overlap. That's where it works for both. Okay? Does that make sense? Yes? All right, we got 2 more. You try this one. And it has purpose. I know I'm trying not to just take up time. It does have purpose. So let's check this out. It is doable. Okay? I did, but I didn't really see what your answer was. You know what I was looking for? No solution. That's what I was looking for because, listen. Shush. Okay? They are parallel. But watch this. Not all parallel, I mean, if it's just a parallel system, where do they intersect? It's no solution. But what if it said, and let's graph this first. 1, 2, 3 over 1, up 3 over 1, up over 1, up 3 over 1, down 3, left 1, down 3, left 1. And so the first one, we do want a solid line. Bingo. Okay? And then the next one is down 2, 3, 4, 5. And so up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. And the second one, we want a dotted line. Now, what if I said, what if I said greater than this one, less than that one? You would want where? In between them. So it's not always, if they're parallel, going to be no solution. Okay? If I said greater than this, less than that, it would be all these points in between it. But the problem is it says, this one says we want all of these points, yeah? And this one says we want all of these points, okay? So, and that's what it gave you on your calculator. So, where do they overlap at?
Nowhere.
No, they don't. And so the answer is no solution. There's not, these points work for that, and these points work for the bottom one, but there's not a place that works for both. And again, Sean figured it out because he said he put them into his calculator. Let's clear it out. Let's put in 3x minus 2, and let's put in 3x minus 5. Check, check. Where do I make the top one graph? Up or above or below? Above, because it's greater, and the bottom one is below it. Okay, everybody good with that?
Yep.
If I graph it, again, these points work for that one. And these points work for that one. But where do they overlap at? Where's the dark part?
No.
There's not a dark part. It's just a strip of blank. Okay? But do you understand, though? What if I had reversed it? What if I had said, I want less than, let's see if I can go less than, hold on, above, below, and I want greater than, enter, that point, where would it shade? It would shade that way, and then it would shade that way, but where's the point where they overlap? In between. Does that make sense? These would be the points if you reversed it. So it's not always going to be no solution. Just remember, if it asks you to shade one way this way, one way that way, they don't overlap, then it's no solution. Okay? All right. Last one. This is, and I'll even do candy for it, this is what you will probably see on the SOL. Give me 3 points that would satisfy this system. But I do like what JT and some of you did the best. You graphed this, -2, and then you went down 2, right 1, down 2, right 1. You graphed, 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 graphed. Okay, dotted line, right? I saw that. And so tell me, where's greater than? A or B? A. Okay, so you know you're going up. Then you graphed this line, and you went up 1 over 2. You graphed this line, or down 1, left 2, 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 oops, left 2, and it's a dotted line, okay? And it says greater than, so you got 1, 2, 3, 4. We want greater than this line and greater than that line. So where is above this line and above this line at the same time? 2. So so from there, he didn't even shade. He just went point, point, point. How many of you did something like that? Okay. You plotted your lines. You figured out which section to shade in, and then you gave me 3 points in that line. Does that make sense? Well, that's fine. That's fine. Did you use your calculator? And that's fine too. How many of you used your calculator, saw that section, and then again, just make sure. Kathleen, what yours? See how I think what was your first point? 0, 3 or something? Or see how it's on? Now, this would work if what? If it was equal. But since it's not equal, these points don't work. Does that make sense? So you gave me points that were actually on the line. So you make sure you go above the line and get greater than. Okay? Yeah, go